So here's our last example. Example 5. So we've looked at polynomials, we've looked at rational. Now let's look at an algebraic. We want to find these limits to determine the end behavior of this one. F of x is equal to a 10x cubed minus 3x squared plus 8 over the square root of 25x to the 6th plus x to the 4th plus 2. All right, so that's what we're looking at. We're going to take the limit as x approaches infinity and negative infinity. Now that's a 4. I just looked at that and it looked funky. Let's try that again. Okay, so here is the same deal. We're still looking at, this is rational, so we're still looking at that denominator, but look at what's happening here. When we have this x to the 6th and this x cubed, if I take the square root of x to the 6th, that equals x cubed, right? Okay, so that's the kicker, and that's what we're going to use here. All right, so let's do this thing. If I take the limit as x approaches infinity of 10x cubed minus 3x squared plus 8 over the square root of 25x to the 6th plus x to the 4th plus 2, then we multiply by the highest exponent, and that is x cubed. And in the denominator, it's x to the 6th. Do you see that? Okay, so I'm going to write it as x to the 6th because I want to keep it under that radical in the denominator, but in the numerator, I can just write it as x cubed because that's my polynomial. So let's do this thing. I now end up with 10 minus 3 over x plus 8 over x cubed. Down here, I've got 25, because x to the 6th and x to the 6th, right? Plus 1 over x squared plus 2 over x to the 6th. We're just taking that x to the 6th. As long as it's under the same radical, then you can work with those. Okay. So when you take this limit, again, 0, 0, 0, 0. So we have 10 over the square root of 25. So 10 divided by 5, technically, because that's a square root of 25, right, is 2. All right. So if you have that algebraic, which is those radicals that you're looking at, then you can work with those. What if I'm going from negative infinity? So the limit as x approaches negative infinity of 10x cubed minus 3x squared plus 8 over the square root of 25x to the 6th plus x to the 4th plus 2. Okay, I'm going to zoom in a little here. The same concept applies, is still the square root here of x to the 6th is equal to x cubed, right? But here's the deal. I'm going to negative infinity. Right? So negative infinity, and I have this odd exponent here. Oh, there's my graph of it. I'm going to scoot it down to get it out of the way, and we're going to see it here in just a minute. So when I multiply here, I'm going to multiply by negative 1 over x cubed, but this x to the 6th is still going to be just x to the 6th because that's that even exponent. When I go to negative infinity here, then I have that negative x cubed with that negative exponent, and then I have that x to the 6th because I'm going to negative infinity because it's that even exponent. Okay, so you got to watch those positives and negatives. They make a real impact. So this is negative 10 plus 3 over x minus 8 over x cubed. And I've got 25 plus, again, because that's an even exponent, I've got 1 over x squared plus 2 over x to the 6th. So this is negative 10, we know, plus 0 over the square root of 25. And that's going to hook me up with a negative 2. Watch those negatives. That's the moral of this story. If you're going to positive infinity or negative infinity, all of those rules that we talked about, you have to pay attention to those. And when you pay attention to those, then you can see it. All right. So here, because I think it's good to look at the different graphs so you can see what's going on with it, I'll zoom in so we can see it better. Here is my function. As I am approaching positive infinity, right? I'm approaching positive infinity. My graph is right here at 2. It's hugging that 2 line. As I'm approaching negative infinity, my graph is hugging that negative 2 line, because this is the actual graph of my function.